Okay, YouTube, this is just a really quick example video of how we could use sum and difference formulas to rewrite expanded expressions that are in a sum and difference-y kind of form into a condensed expression. So up until now, we've just been using sum and difference formulas to take a condensed expression and expand it into this exact value expression over here. What I want to do is I want to go back the other way. So these are pretty simple to do. We'll refer to these sum and difference formulas on the right to get these over here, but we say let's write the expression as the sine, cosine, or tangent of a single angle, whereas this first expression we have cosine 25, cosine 15, sine 25, sine 15, or this is supposed to be a sine, pardon me, sine 15, but I want you to recognize here that of all three of these sum and difference formulas, this is applying to the cosine sum and difference formula. So when I look over here, we say cosine u, cosine v minus plus sine u, sine v. We need to identify what our u and v are, and it looks like our u in this case is 25 degrees. And our v value is 15 degrees. And in this case, we have a minus here, or a subtraction sign, or a difference. And so since that is backwards of what we would have in our condensed portion of this, this must be a sum. So we say this could be rewritten as the cosine of u plus v, where in this particular case our u is 25 degrees and our v is 15 degrees. So in other words, this original expression could be written as the cosine of 40 degrees. Okay. Likewise with our tangent here. We're obviously using the tangent sum and difference formula, and so we'll recognize u and v. First of all, u and v would have to be respectively 325 degrees for our u, and v is 86 degrees. And I notice that this is a difference up top, which, by the way, has to be the same as what I would have in this tangent of the sum or difference of the two angles themselves. So we'll say that this is a sum that we're using here. We could also recognize that in the bottom here, this was a plus, and that's backwards of what we would start with. Okay, so we would say in this particular case, we say that this must be a difference. So we have the tangent in a difference of two angles. We say 325 degrees. This would be 86 degrees. And so we could actually just get a calculator out here. We say, okay, 325 minus 86 be 239. So this original expression could be said to be the same thing as a tangent of 239 degrees. And then last but not least, the sine expression down here. Now, I want you to notice this. We have u and v here, but it says sine, cosine, cosine, sine. Obviously, we're using a sine sum and difference formula here, but I notice that up here it goes u, v, v, u. The thing is, down here, when I wrote it thusly, I say u and v and u and v. The idea here is we can obviously recognize that u is 140 degrees and v is 50 degrees, but that I switched the order of cosine and sine around so that it's not sine, cosine, but cosine, sine. And the only reason I did that is because I wanted my u's and v's to go in the same order, and it doesn't matter what order we multiply in. So cosine, sine would be the same as sine, cosine with these respective angles. So we'd say that knowing that sine, looking at the formulas up here, sine adopts the same SIGN sign as was adopted over here or was given over here, then this would be the same thing as the sine of something plus something, where we have these two somethings are 140 and 50 respectively, and no calculator needed here. We could say that the original expression is the same thing as the sine of 190 degrees. Cheers.